Hello, welcome to this video on FPOD data validation. So we're trying to find out if the automated classifier, which is in this case the Kerno F classifier, got the right answer or the wrong answer. And the essence of this is that we've got to take a kind of wider and more intelligent view of the data than the classifier did. And this topic, recognizing cetacean encounters, is like the widest view and is particularly interesting. So what we'll do is um, look at this file, which has 160 days of data, but here we're looking at it in 100 millisecond resolution, so we're in high resolution, and we're looking at just other cetaceans and the high and moderate quality click trains. So we go show next screen. So this is the first thing the classifier thought was a dolphin. And to look at the encounter, by encounter, what I mean really is the dolphin swam into the range of the logger, the FPOD, and eventually swam out of its range. So to get back to the start, I'm just going to use the left arrow to move earlier, and you can see a lot of um, packets of sound at the bottom there that look very much like dolphin click trains, but they weren't classified as such. I'll just hit the F4 key to let everything in, so that removes all the filtering. Note one of them here was classified as low quality, but it wasn't given a species. But what I really wanted you to notice is the amplitude here is tending to get weaker as we go earlier in time. And then we get back here, there's practically nothing going on. And prior to that, there's something very noisy that's maxing out the system early in every minute, and doesn't have any trains extracted from it. So we'll just move to the right later in time and we see this encounter beginning to develop. I'll just scale those amplitudes down. Sorry, went the wrong way. And it goes through to this point here where they're recognized by the classifier. And then 3 minutes later, it's down to practically nothing, and yet it's gone basically. So that was a very brief encounter, and it's kind of classic, it's a gradual ramp up and a sharper fall off because the animal's sound beam is pointing ahead of it. And that's very supportive of that classification, at least as being a cetacean. So we're now back to just other cetaceans. Show next screen. So it jumps forwards until it finds the next click trains classified. Now these look pretty unimpressive actually. They're very weak. Down here it's almost continuous low frequency noise. We kind of really want it to be in packets. So rather than diving deep in here, we're looking wider. We'll go earlier in time, and this kind of weak low frequency noise is getting even weaker, and now it isn't there. So we'll go back the other way. We're getting towards so that's where it's. Let's just raise this up a bit and zoom in. Can this really be click trains here? Yeah, when we zoom in, that does plausibly look like click trains there. Just zoom in a bit further on yeah, I think you've got two click trains overlying one another here, but it's certainly not random. You can see there's regular intervals being repeated there. So we'll just go to this earlier period here and hit the graph button. So we're just getting a very dominant low frequency spike here at 18 kilohertz. Very weak clicks, as we'd already recognized. Whoops. And we'll go later in time. There's the clicks that were recognized, and you can see, well, maybe we won't look too deeply into that. Okay, we're going on in time and we're getting a lot more clicks. Some of them are picked out as dolphins. I'll just hit F4 to suspend all filtering. Let's just zoom in on these again. Yeah, these are clearly click trains. And we'll just do the graphing again. So now it's got louder in the raw data. We've got a frequency hump appearing here at 40 kilohertz, and that's reflected in the click trains that have been picked out. So we'll move on in time. Okay, it's getting really loud now. I'll have to scale it down a bit and just hit the graph button again. Well, you can see some higher frequencies appearing in the clicks that were found to be in trains. And we'll go on in time. Okay, now the clicks are coming so thick and fast that it's maxing out the minute here. And I'll just scale this down and hit the graph button again. So now quite a lump is appearing down here around 110 kilohertz. So we're getting more high frequencies showing up. Go further along, hit the graph button again. Yeah, these higher frequencies are getting more prominent. So what's happening here is that this is a cetacean encounter. The early parts of it, the dolphins, are so distant that their high frequencies are being absorbed by the seawater, because seawater absorbs ultrasound more strongly when it's at higher frequencies than lower frequencies. So that peak down there at 17 kilohertz has now been replaced by one at 120 kilohertz. And we'll keep going on in time. So it's getting sparser, getting weaker, and it's practically gone. So maybe they'll turn around and look back. Yeah, maybe there's just a little bit of data there. So that was a complete encounter, much longer than the other one, but it showed the same feature of a gradual ramp up in amplitude. And I'll just go back through it because the amplitudes have now been scaled down. So you can see here they are at their loudest, and back here they were really very, very much weaker. So I won't labour this too much on dolphins. What we'll do is just have a look at some porpoise detection. So show next screen. So, well, this one's a trouble straight away, because here's something that the software is claiming is a porpoise click train, but down here there's something that looks very much like a dolphin click train. So I'm just going to scale that up a bit and just zoom in here. Yeah, these are very good click trains, but you can see the frequencies there are up in the porpoise range, and here they're definitely not. So the question is, do we have both species at once? So a good way of looking at this, um, well, maybe I'm jumping the gun a bit here. Let's just go earlier in time like we did before. So these are the kind of porpoise frequencies, and if we move earlier, yeah, we've got very nice looking packets of noise from dolphins. Nothing very sort of uh, isolated up here. They're part of, um, yeah, and then as we go earlier, it kind of fades out. So that's before it starts. Um, so we want to see if there is a porpoise encounter kind of embedded within the dolphin encounter here. So let's make this one MBHF index. So this is an FP1 file, so's that, and this is an FP3, and so's that. So, um, okay, so we're getting really high NBHF index here, which is sort of strongly indicative of being a porpoise. But here they're getting pretty sparse. You know, you get isolated high ones from dolphins, occasionally from moving sand. We'll look earlier. And none of this is high. You know, it says nothing suggestive of porpoises there. Um, but here, um, it's really looking very plausible that these are porpoises. Just see what the graph looks like. Yeah, so the graph is giving us a big peak at porpoise frequencies and then quite a gap in there. If you think back to those dolphin uh, encounters earlier, there wasn't that huge gap in the distribution of frequencies. So I think this actually was a porpoise encounter embedded within a dolphin encounter. So just risk my luck here and do. Okay, so here's the next porpoise encounter. So lot of good high NBHF index. We go earlier. Yeah, they're sort of fizzling out. Nothing there. Okay, so it's getting stronger, getting detected very strongly. Goes on for a bit, and then it's pretty much gone again. Well, a little bit there. Are these actually click trains? Yeah, they're very few. They're kind of train fragments. You know, it's clicking very slowly, and as the porpoise swings its head around, when it's clicking slowly, the pod only gets 2, 3, 4 clicks, and it never says that's a train. 5 is the minimum it will claim is in a train, and then it's gone. So actually, you find a lot of these detections do fall within recognizable encounters like this that have these two characteristics of a gradual ramp up in amplitude, um, and then a much more rapid fall off as the animals have swum past the logger and are going away. So um, I think what you have to do is kind of look at lots of them for yourself, try using different parameters, but frequency, amplitude, and NBHF index are really useful for this. Um, and um, yeah, just to say that the dolphins there were probably common dolphins, but we're not absolutely sure. And thank you for your attention. And thanks to Paul Semmons for this picture.